I'm at Kempton Steam Museum in front of some of the biggest working steam engines in the world. They were made in the early 20th century to a highly efficient design and pumped water into the homes and factories of London until 1980. I'm not here because there's anything very biological about steam engines. We don't burn our food in furnaces or boil water to move our limbs. I'm here because the whole science of energy started with these machines. It was engineers like Thomas Newcomen and James Watt who invented these engines, first to pump water out of Cornish tin mines and then to power the Industrial Revolution. And it was scientists who figured out how they worked, why some designs were more efficient than others, and what energy was. James Joule and Lord Kelvin in Britain, the French genius Nicolas Carnot, Rudolf Clausius in Germany. They invented a new science, the science of thermodynamics. We still use their results and their names when we describe energy today. Thermodynamics is a combination of the Greek words for heat and energy, and the early thermodynamicists wrestled for decades with the relationship between those two things. Was heat the same thing as energy? Was it conserved during a process in the same way that matter was? And what was the difference between temperature and heat? It was Joule who worked out that work and heat were two aspects of the same thing, energy. For this insight, he is often credited with discovering the first law of thermodynamics. Heat is work and work is heat. They are both manifestations of energy in living things, just as they are in steam engines. And Joule found it was energy, not heat, that was conserved during a process. While energy cannot be created or destroyed in a process, it can be dissipated uselessly as heat, instead of being used to do useful work. Carnot and Clausius together are credited with figuring out the relationship between temperature and heat. Out of that work came a new fundamental quantity, entropy, which you will meet as you learn more about thermodynamics. By the end of this week, you'll be able to do simple thermodynamic calculations and apply them to biological systems, quantifying energy flows in the human body and beyond.